I'll show you this one. So this part is a flex part. Flex, let me show you here. Flex valve. So, yep. So it's a valve just gonna just control. Yeah. I think, let me show you here. I think this one is here. Sorry. So እዚህ ጋር ስንት ጋር ነው የሚሸከመው? You see, from 300 to 900, 300 to 900 psi. Let me check them out. A1.
ፕሮፌሰር አይሰማም
አይሰማም እንዴ? እኔ እኮ መሰሙት መስሎኛል እኮ
ሼር
ስታረግ ያልኩት እኮ እንደዛ መስሎኝ ነው።
አይሰማም
ሼር ሳውንድ በለው
አይሰማም
አይደል? ባይስተ
ሼር ሳውንድ በለው ሼር ስታረግ ሼር አደረገ
Okay, share sound, share man dalona. Anyways, so this is just a valve, okay? Valve nacho. Now they control, you know, it's like high pressure. You're gonna just hold very huge amount of like mass. You're gonna hold a very huge amount of mass using like those valves. So I'll show you what it is. Then you're gonna learn from that. So this is a part, DTDF and DTDBF. So those are like the part number. So it is project that's gonna just utilize just to solve like what is a leak problem. So this is the cross-functional team, formation of like cross-functional team from each department. So we have like quality here, we have like supplier quality, Cartijor, like this is a engineer, and these are like operations. Rob Bachman is manufacturing, you know, just like that, okay? So we're gonna do like departments just like that. Then as you see here, the problem is this is a defined phase. So the flex parts not consistently pass leak test. So purpose, this is to identify potential sources of process variation. You see, this is what I told you earlier. This is what I told you earlier. Can you just mute taragator? smoothen. So all potential sources of like product or process variation. That's what you see in a defined phase. Then that impacts leak and first pass yield to acceptable level. And CTQ is customer's cost function, and improved ODT that reduce like lead time. And scope, that's what I told you earlier, includes the entire process. Where we are going to do it? Is that in our facility? Is that in our supplier facility? Does that go to any other lab or whatever? Those are like the things. And consideration of food given to eliminating internal operation, just like that. Then the project benefit, this much is for repair, this much is for scrap, and this much is for rework operations. And it's gonna just add to like 5 million. We're gonna just produce about like this much bulbs. This is put in the defined phase. But like when you start, okay, when you start study, then you can write this one. You are okay with that. You might be okay with this, but you might not have like information about this. But this gonna be just calculated, okay, calculated using like cost engineering plus or recalculated. Okay, both is gonna be just work, not one way, okay? So the major phase, data collection system, development of process map, and internal data and supplier data. So who's gonna just work with internal data? These are like the guys do the internal data, okay? Then supplier data, this guy is gonna just do that, okay? From this company is in Chicago. Then here, now we're going to look at like the parts. There are two important parts. One is the sleeve, and the other part is puppet. So I'll show you here. These are sleeves, and these are like the puppets. So this is another company called Pretech, and this is another company, Pretech. In Pretech, this operation is done. Okay, this operation done in Pretech. Okay, then another company, they're gonna just move to another company. Then they're gonna just do like metals tech. So this is all about heat treat. So here, string is the thing that we're going to just look at. And Asteroid is the final company who's going to just deliver us after they do, super finish, like machining parts. Okay, then we will get those parts. Then operation starts here. Operation starts there. And the other is these are like the puppets. Yeah, these are like the puppets. So how many companies here? Braico is gonna just do the first operation. Then Metaltech is gonna just do the second operation. Sequential, vertically integrated operation, okay? Then one part, this one comes through Asteroid, and these parts is gonna come through grind, and these two parts come through SPA Oreo. 40 or 40, I don't know. Then finally, we got those parts and move to our receipt that's internal. Then our operation just starts right there. So this is the overall process map for the part. So these are the way we do the assembly of the process. So those are like the parts, and this is called like process flow diagram. Then these all steps is going to follow one by one, okay, one by one, okay, and like these are like sequential operations. Then parts are going to just assemble. So all these things are measured in what? In the measure phase. Process flow diagram, okay? Because that's going to be just important for us right here. And the next phase is to conduct fishbone diagram. This fishbone diagram is still in the measure. Do you know why? Because this is all previous studies. ናቸው እነዚህ ገብታችኋል? previous study የተገኙ ስለሆኑ then that is still in measure phase. So environment, temperature and humidity, warehousing and material handling, okay? You see? Then personnel, procedure. They do not just follow like procedure because they are well trained. Process, incorrect coining. This is ME problem, manufacturing engineering. Insufficient application of puppet and sleep. Incorrect installation of ID shields. Okay? That's a part of like this one. Installation of tube in hex body. Hex body is there is the shape of the part which look like hexagon. And incorrect installation of spring, incorrect installation of seals and glide rings, and wrong rack wash and improper transport. These are all put in process. Then here, gauging. Engage, calibration, device or measurement device, calibration inadequacy. Sometimes the calibration might not be also okay. Gauge performance, the gauge might not be accurate and precise. And overall gauge R&R on system. So it's going to just tell us the variability from the process plus variability from operators. This one, the machine, parts not, correctly loaded to the wash, incorrect water cycle, coining. Coining is a process where, it's like there is a ball, that ball is very rough inside. So to make it very smooth, what they're going to do is they put the ball and they're going to press it with the pressure. So when the ball is pressed by pressure, so it's going to just deform the surface. So that makes the part to be good. So improper tube torque, water supply, oil temperature. So this oil temperature, if the oil temperature rise, viscosity of the fluid changes. If the viscosity changes, then the flow rate is changed. So flow rate that's a leak. That might just cause like leak. Then material, push force on string, puppet, roundness and concentricity, sleeve, roundness and concentricity, puppet, surface finish, puppet, see geometry, nicks on the puppet, sleeves, see geometry, and burrs on a sleeve. Burrs on a sleeve, spring lengths, all these things are like in the material. And the problem is leak. Leak is a problem. That is our what primarily focus, and that is in the defined phase. Defined phase, okay? We put that information in the defined phase, okay? So that's why we collecting that way. Now, key pointers, still in measure phase, we completed assessment of essential matrices at measure phase. Preliminary fishbone diagram gives an important clue for about like how to proceed the next step. At this stage, the team deals with identification of essential quality parameters for the leak problem. Okay. Now I'll show you here. So here is the case. So this is the inside of the inside part, and this is going to be just plugged right here. So I'll show you here. So this is the part that we're talking about. This part is the one that we are talking about. So where is leak happen? Leak is going to happen here. Here. Leak is going to happen here. So አሁን ምንድነው ሊክ ሀፕን የሚያደርገው እዚህ ጋርና እዚህ ጋር ነው። በምን ይመጣል ከተባለ አንደኛው I'll show you here. So okay, I'll show you. አሁን እዚህ ጋር ያለው አንግል አለ። እዚህ ጋር ያለችው አንግል አለች። አንድ እሱ ነው። ሁለት ከዚህ ያለው ርቀት ነው። ምክንያቱም እሱ ከበለጠ አንግሉ ትክክል ቢሆንም ሊክ ሊኖር ይችላል። ሌላኛው ደግሞ ይሄ አንግል ትክክል ሆኖ ይሄ ዲያሜትር ትንሽ ከሆነ የሚቀጥለው ደግሞ ይሄንኛው ነው አይደል ስሊቭ የሚባለው this is sleeve. So እዚህ ጋር ያለው ዲያሜትር አይዲው ትልቅ ከሆነ or like here concentricity, this is a concentricity with like the sleeve, the puppet right here and the sleeve right here and so forth like that. And here the other section when pressure just applied, if the spring force here, spring force K, if it's going to be like either high or low, corner, overall lengths for this one, these are all affecting parts performance with respect of like the leak. So now, as I told you, this is a part. Then we are going to make section it and looking the part just like that. So when it's going to just disassemble, so this is a sleeve, this one, this is spring, this is retailer ring, and this is a puppet or piston, okay, just like that. So now leak is going to just happen here. That is how we're going to deal it. Then the next step is we identify quality parameters. So those roundness spec, runouts, location, RA is just roughness, average roughness, RG is the peak roughness, and this is go-no-go gauge, like go-no-go gauge, like measurements, but like those are like found in the part. And from the puppet, steam diameter, RA, which is surface roughness, and RZ, surface roughness. Theta angle, I already just told you earlier. Gauge length, that's the overall length of like the part. And roundness, a seat spec, roundness on the seat, run out on the seat. RA, that's also roughness on the seat, and RZ. So those are the critical parameters for the leak. And the next phase is the analyze phase. Okay, the analyze phase. So all this phase, early phase, all these are like in measure phase. Review of the design, everything is gonna be in the measure phase, and this is on analysis phase. So how we're going to just approach from data to model approach. Okay, data to model approach. What is that? We have like data, then we're going to just deal with which model is going to be appropriate. So the principle is the right model should select for the right data. So assumption, no normality is assumed. Okay, normality. So, and this technique is much stronger prediction power than the classical model because no assumption of normality. So now I'll show you here. So this part is earlier we already just discussed. This is the sleeve. Okay, that's the sleeve. Now this is process capability index for roundness. So what we find is PPK first, when we do like the distribution, it's not normal, and we found both Johnson transformation the best fit. So when we do like the PPK, we found 0.14, which is much less than the expected or the allowable or the standard of acceptance. So that means if this is the case, only our yield is 92%. Okay, then do same thing for all of like parameters. So we found, roundness on the seat spec is unacceptable or less, but others are like yellow and green. Like when you say yellow, as you see where it's sigma level here. Okay, actually CPK, you're gonna learn about like CPK later. But the other like steam diameter, RA, RZ, angle, all these are okay. When I say, you see, for example, this is normal, and we found like CPK of 2 or 6 sigma. So that means the process performance in producing RA is excellent. So we don't have any issue with the stuff. But like when it comes to like seat roundness, that is low performance. So when we multiply those probabilities, what we find is 88.93%. So what does it mean is that in producing in current process, the production of that sleeve is good only 88.93%. Okay, so what it means? Then similarly, we do those things on the puppet or the piston. So roundness, again, showed like CPK of this. So it's in warning stage, but others are like relatively greater than 1 sigma level. And this is like just to sigma level. Okay. Actually, this is what I already just told you earlier. This is less than 3 sigma, greater than 6 sigma. This is just unacceptable. You know, sigma levels are already just identified. So when we do like the calculation on the puppet, for single puppet, this is the probability of getting good puppets with respect of like leaking. Okay, no. This is sleep. Okay, sleep. So this is the probability. Okay. And all these are for the puppets, yeah, for the puppets or the piston. When I say piston, I'll show you. This is a puppet. This one is a puppet. This part here, and this is the piston. So now I'll show you. So this one, sleeve, this much percent, and puppet, this much percent. So what's going to be the total assembly is going to be 73%. That means what we look at is above 95% of yield, but here only 73% of yield is achieved through leaking because of performance level. And now, then this is further analysis. We have like 30 parts, and we're gonna do like this comparison, all the specification given, and we do like a binomial approach just to calculate that stuff. And all those parts are like failed, and diameter, RA, RZ, you know, all these are like good number, but when it comes to roundness, it is bad. 50% chance on the seat, So critical finding, the result showed that 50% of the failed parts out of because of the spec of seat roundness. That's what we find. Next. And here on a puppet, like sleeve, so as you see, seat angle, those two are like failed. Seat roundness, those are bad, and the prediction is bad, and those are categorically correlating, but the other are not like as such correlated. So 92% of failed parts showed out of spec for seat roundness. Then go, this is interaction effect. So roundness, leak test, seat angle. So roundness, pass, seat angle pass, and that cause the part to be pass. So pass combined with pass is gonna just test the leak test, pass the leak test. This is, if it's gonna be roundness is pass, but seat angle is fail right here. So the overall test is gonna be fail here. Okay, seat angle pass, roundness fail, okay. Pass fail combined is going to be just right here. So how we are going to find it? The pass fail, the test is going to be again fail here. Okay, so fail is going to be like fail. So in general, bad, good, bad, good, bad. So this is all like probabilistic scenario. So good. If all these three are good, and 96%, that's what's gonna just predicted. So the other factor was spring. So from spring, when we define applied force, that's pressure to contact area. So force is spring constant times change of X. So now when we just combine these two, change of X is a function of pressure applied, which is variable, and spring constant, K. So spring constant is a function of, again, material. So the magnitude of applied pressure during the test is determined by following procedure during the test. So that means the amount of pressure that we achieve during the test is based upon like the calibration, based upon like timing, based upon the alignment. All these things are like work procedure. So here, human error might just occur right there. And the other is spring constant. So from that, we learn, you see, when we study the distribution, spring force for load 1, that is 3-parameter Weibull, but high performance. Load 2, low performance. Spring force rates, that is high performance, overall 99.39%. So spring force is not the major factor for the leaking problem. That's what we discovered. And now here, this is independent t-test. So these independent t-tests, those are like failed parts roundness, and these are pass parts roundness. So these are like more precise and also low. But this one is imprecise plus high with respect of like the nominal, with respect of like roundness. Then the next phase is analysis before and after heat treat. So you see, this is pre-treat, after heat treat. So after heat treat, it's going to just show bad measurement. But after grinding and after wash, it's going to just getting down. That means if we have like good parts here, then we're going to get good parts there too. So when we do like Fisher, category, this is what we find. So the ANOVA test confirmed that the parts showed significant improvement, roundness after grinding. So grinding is most important operation again. This grinding operation plays an important role for the performance. Then the next phase is brushing. You see, this is after brush, but this is before brush for roundness. So what we want is, it should be less than 30. 30 is right here, right here. You see, before brushing, everybody was failed. But after brushing, only these parts failed, but the other pass. So pair t-test confirmed that after the brushing operation, the parts showed significant improvement on seats runout. Thus, the brushing operation plays the most important role in improving product performance of the leak. Then here is sequential CPK. So you don't know this index now, but you'll learn for that one. But this means bad. This means bad. And this is relatively good, but this is bad. Okay? So this is just with respect of like machined parts, heat treat parts, blasted, and grinding. Okay? So that means we need improvement here. Okay? We are almost like good in blasted, but it needs also improvement. But heat treat and machine, they're not good at all. That means the heat treat machine needed abzanyon process variance የሚመጣው okay ከheat treat ነው ማለት ነው ከheat treat ነው ማለት in the machining process. like hey, there are a lot of like machining operation that's gonna just take place. But like when it comes to like blasted, that's relatively fine, and grinding. But like all needed, the team determined that the machine process needed improvement. Like this needed improvement, this also need improvement, but most improvement is needed right here in the machining operation. Then this is the binomial tests for coining part. So that the coining is we're going to put a ball, and we're going to push it. So that makes the inside of the section to become like very smooth, okay, very smooth. So here we took like 42 psi, like the pressure that we are going to give, okay, the pressure we are going to give. 42, 45, 45, and these are like the parts. As 42, 3 failed, and 45 out of like 200, or out of so like 240 plus 300, almost like 297 parts like pass. So when you can do like the binomial test, this is gonna just tell us here is 45 coining pressure is found superior, and we are going to use that. Then improve phase. So we already discovered what is needed just to improve. Owner is assigned at the breaching operation, control plan for breaching operation is developed. Brace must change every 30 pieces. Spindle RPM. RPM is revolution per minute. Should set to 3,000, and feed override should set 200. So that is improved phase. Then continued. This part, machining operation, we already just take it, and this is a company. And grinding operation at asteroid, controlling tools, speed and capability, adequacy of tool life, gauge render steady, and adequate process control, and implement data tracking system so that we need to follow the data. And the coining process set to 45, that's also another control. And this is a control phase. So the before and after. One is SPC. This is implementation of statistical process control at our supplier. And this is what we find. This is the brushing operation. Okay, right here. I'll show you. So this is a sleeve and this is a part. So it's gonna just go inside right here. Then they're gonna just rotate it. So the purpose was to take out like micro particles. But here we already discover those things is gonna just adjust the roundness, make it more round. So this is like the sleeve. So we already just developed work instruction, and this is this work instruction found in the quality management system. Okay, then review of DFIMA. Okay, done. And PFIMA, that's also just done. Then control phase, quality report on the brushing, regular assessment of supplier performance, and implementation of SPC. Those are, and this is the overall, okay, performance, what we did. In the define phase, project selection and project chartering, that's already done. Measure, project description, baseline data, process map, cause and defect, preliminary FIMA, gauge, and SPC. Analyze, variable selection, process modeling, and design of experiments. And improve, design of experiments, improve plan and implementation. And you control dogs, and hands-off training if training is needed, 1 month verification, process owner sign off, and final projects. And this is the 5-step DMIC process. And this is our final data. So this is the one that I told you exactly becomes like 100 after we finish the project. So we hit the target to 98%. We hit the target. So all the calculations that we made becomes like very good. And this is the progress after, the study. And we find those parts getting like good, but this one showed a lot of variation. So further study is gonna just conducted on that part. And the study is finished in this way then. ይህን ይመስላል ማለት ነው። እንዴት ነው? ግልጽ ነው አይደለም? እንዴት አደረጋችሁ?
አሪፍ ነው።
It's clear.
ክሊር ነው?
Yeah.
ስለዚህ እስካሁን የሰራችሁትን ምናምን እያሰባችሁት ነው አይደል? ምን እንደምታደርጉት
ፕሮፌሰር ጥያቄ ልጠይቅ?
ጠይቅ።
ኦኬ፣ እዚህ ላይ አሁን ብዙ ሜጀርመንት ነው የተጠቀምነው። ፓሬቶ አለ፣ አኖቫ አለ፣ ቴስት አለ፣ ሌላም አለና መጨረሻ ላይ ኮንክሉድ ለማድረግ አይቸግርም ወይ ብዙ አይነት እንትን ስንጠቀም?
ምን ማለት ነው ደግሞ?
አሁን የተጠቀምናቸዋል። ፓሬቶ ተጠቅመናል፣ አኖቫ ተጠቅመናል፣ ቴስት ራሱ አለ።
እሺ፣
ኢንዲፔንደንት ቴስት ተጠቅመናል እና ኦልሬዲ ፕሮጀክት መጨረሻ ላይ ኮንክሉድ ስናደርግ የነዚህ የተለያየ ዳታዎች ስፔሲፊኬሽን የተወሰነ ሊሚት አያመጣልንም ወይ ማለት ልዩነት አይኖርም ወይ በሁሉም?
ላቦራቶሪ ሽንት ቴስት ስታደርግ በምንድን ነው? ቀጥለ ደግሞ ላቦራቶሪ ደም ቴስት ስታደርግ በምንድን ነው? ቀጥለ ደግሞ ላቦራቶሪ ቴምፕሬቸር ቴስት ስታደርግ በምንድን ነው? አይለያይም እንትኑ ሜቶዱ? አፍተር ኦል ግን ሰውየው ጉበቱን አሞት ከሆነ ጉበቱን እንደታመመ ትናገራለህ ማለት አይደል? ሶ ሄማ ያወረኮ መሐንዲስ አይደለ እንዴ? So you need to know the models and you need to know where you are going to just apply them. Isn't it? Yes.
For each purpose, we do different.
አይደል? ሞዴሎቹን ትማራቸዋለህ። ከዛ በኋላ የሆነ ፕሮብሌም ሲያጋጥምህ እዚህ ጋር ይሄንን ነው የምጠቀመው፣ እዚህ ጋር ይሄንን ነው የምጠቀመው፣ እዚህ ጋር ይሄንን ነው የምጠቀመው፣ እዚህ ጋር ይሄንን ነው የምጠቀመው እያልክ ትሄዳለህ ማለት ነው አይደል? ተስዋትጂ። ስለዚህ do select the right model for the right data and bring the right conclusion. That's what it is. ይሄ ይሆናል ማለት። ሌላ ጥያቄ አለው? የለም? ገብቷችኋል? አልገባችሁም? እቺ ዝምታ እኮ ነው የታስቀኝ።
እዚህ ለፕሮፌሰር አንድ ጥያቄ ልጠይቅ።
እሺ ዝናቡ፣
እዛ ፕሮብሌም ዲፋይን ስናደርግ ከስኮፕ ቆጥሮ ታይም ብለን ነበርና ታይም ላይ ይሄ ፕሮጀክት አሁን ለመጨረስ ስንት ያክል ጊዜ ተጠቀመ ለማለት ነው?
ብዙ ጊዜ ፈጅቷል። ቢኮዝ ፕሮብሌሙ ኦልሬዲ እንደ አንድ ቦታ አይደለም አይነበረው አይደል? ማለት ካምፓኒዎች ጋር ነው የነበረው። እኛ ጋር አለ፣ እዛ ስፔሻሊ ቺካጎ ምናምን የነበሩት ጋር ብዙ አለ። so it takes a long time. ግን አሁን ምንድነው ፕሮጀክት ስኮፕ ላይ ግን አለ፣ በዚህ ቀን እንጀምረዋለን፣ በዚህ ቀን እንጨርሰዋለን ተብሎ የተቀመጠ አለ እና በዛ ጊዜ አንዳንዴ ታይሙ ሎንግ ሊሆን ይችላል፣ ሾርት ሊሆን ይችላል፣ አንዳንዴ ዳታ ላይ ያገኝ ይችላል። ብዙ ኮንስትሬንቶች አሉ። ሶ በዛ የተነሳ ወደ ላይና ወርታች ሊል ይችላል። ይሄ ግን it's like it was hidden እኮ for ለ10 አመት ነው ምናምን ተደብቆ የነበረ ነገር እኮ ቀላል ፕሮብሌም አይደለም። ምንድነው ይሄንን ኮዝ የሚያደርገው? every time ሊክ አደረገ ይባላል። so there was like a big problem. እንደዛ ነው። ግን ያው ፕሮጀክቱ ስኮፕ መቀበል አለበት ማለት በዚህ ከዚህ ቀን ጀምሮ እዚህ ቀን ማለቅ አለበት